Hey guys, it's Miss Johnson here, and I'm here to bring us our last video from Chapter 7 on solving radical equations and inequalities. Excuse me. So we are going to be solving radical equations today. We're really using the properties and the principles that we have always used for solving equations. We just now have to put the radicals in them, and we need to think about how we would simplify radicals and what we do with those radicals. Everything else that we will do today, we have done before. Your example up at the top is really just a piece of simplifying. It says computer chips are made from the element silicon, which is found in sand. Suppose a company that manufactures computer chips uses the formula C is equal to 10 times n to the 1/3 power plus 1500 to estimate the cost in dollars of producing n chips. Now the question they're asking us is what would the cost be if we produce 27,000 chips? So this becomes Rn. So I'm going to take that and I'm going to plug it into my formula. I have 10 times 27,000 to the 1/3 power plus 1500. And I really just want to use my properties of simplifying there. I can take 27,000 to the 1/3 power, or in other words, I can take the cube root of 27,000. Remember from 7.6 we looked at how we changed those rational exponents into radicals. So I'm looking at the cube root of 27,000. When you plug that into your calculator, 10 times the cube root of 27,000, which is 30, plus 1500, and then 10 times 30 is 300, and I end up getting a total of $1,800 here. Okay, so again, I'm just using the principles of simplifying and solving that I've always used, but now I have some radical expressions in them. So let's take a look at some examples together. Number one, I have the square root of x plus 1 plus 2, which is equal to 4. I'm trying to solve for x there. So the first thing, we have to get rid of everything outside the radical first. I can't do anything with the radical until everything that's outside of it is gone. So the first thing that I have to take care of is get rid of that constant of 2, and I'm going to do that by subtracting. That leaves me with the square root of x plus 1, which is equal to 2. 4 minus 2 gives me 2. Okay, great. So now on the left-hand side, I have the square root of x plus 1. Well, I have to get x out from underneath that radical. And in order to do that, I need to square the radical, because the power of 2 is going to cancel my radical sign. Well, we all know that if we do something to the left, we also have to do it to the right. So then I square the right side as well. Now I'm left with x plus 1 is equal to 4. Last step, we all know what to do with this. I'd subtract the 1, and I'd get x is equal to 3. Now, before you put a circle around that and decide that that's actually your answer, you have to check it. Okay, radical equations are notorious for leading to extraneous solutions, which means they're solutions that you get after you square something or after you manipulate the equation somehow, but that it doesn't work in the original one. Okay, so I have to check my answer. So I'm going to take the 3 and I'm going to plug it back in. I have the square root of 3 plus 1. I have plus 2 outside of that, equaling 4, and I want to ask myself if that's true. Square root of 3 plus 1 is the square root of 4 plus 2. Square root of 4 is 2, and I end up getting 4 equals 4. So I know that that's true. I know that 3 is my solution. Okay. Let's take a look at number 2. In number 2, I have the square root of x minus 2, which is, oops, back on this page. The square root of x minus 15, there we go, is equal to 3 minus the square root of x. So now I'm looking at two values of x there. Let me get rid of my ink here. Get rid of my piece of cake. So I need to start by squaring both sides to get rid of that radical. So I'm going to start by doing that. Okay, so if I square both sides, okay, I'm squaring the whole thing. Now, on the left-hand side, everything's under the radical, so that just cancels my radical and my power of 2, and I'm left with x minus 15. On the right-hand side, I have a binomial that's being squared. That means I have to use FOIL to distribute that out. So let's FOIL this out and see what happens here. I end up with 3 times 3, which is 9. My outside terms are going to be minus 3 times the square root of x. My inside terms are going to be minus 3 times the square root of x again. And my last two terms, I have the negative square root of x times the negative square root of x, which gives me a positive x. That would give me a positive square root of x squared, and the square root of x squared is just x. Putting all that together, that's 9 minus 6 square root x plus x. Okay, now let's keep solving here and see what happens. I have x's on both sides. If I subtract an x from this side to get rid of it and subtract an x from that side to get rid of it, my x's actually go away. X minus x is 0, x minus x is 0. So that leaves me with a negative 15 equaling 9 minus 6 times the square root of x. I'm getting closer. Now I only have one variable left to deal with, which is good. I'm trying to get that variable alone. I have a constant of 9 that I have to subtract. Negative 15 minus 9 gives me negative 24. These go away. I'm left with negative 6 times the square root of x. Almost there. Divide by the negative 6 because, again, I got to get rid of stuff outside the radical first. I'm left with a positive 4 equaling the square root of x. And then one last time I have to square it. So I square that and I end up with 16 equaling x. But again, before I circle it, I need to plug it back in and see if it works. So I'm going to do that. I'm going to take the 16 and I'm going to plug it back in to see if it works in my equation. So I'd have the square root of 16 minus 15 equaling 3 minus the square root of 16. Well, 16 minus 15 is 1, square root of 1. 3 minus the square root of 16, which is 4. Square root of 1 we know is 1. 3 minus 4 is negative 1. Uh-oh. I ended up with 1 equaling negative 1. Now we all know that that is not true. So in this case, I actually end up with this is what's called an extraneous solution. So I have no solution here. Okay. Let's take a look at number 3 and give that one a try. Now I have the square root of x minus 2, and then minus 1 outside the radical is equal to 5. I'm going to start by getting rid of what's outside the radical. So I add 1 to both sides. I have the square root of x minus 2 equaling 6. Now I have only the radical left, so I'm going to square both sides because that power of 2 is going to cancel my radical sign. That leaves me with x minus 2 equaling 36. And then I add 2 to both sides, and I get x is equal to 38. Again, before you circle it, you got to make sure it works. So I end up with the square root of 38 minus 2, and then minus 1 on the outside equaling 5. 38 minus 2 is 36, and it looks like it's going to work out for me. 6 minus 1 does give me 5. 5 does equal 5, so I'm good. 38 is my solution. Okay. Let's do one more example together. I'm going to get you started with number 4, and then I'm going to have you finish that one on your own. In number 4, now I'm dealing with that rational exponent. So I need to figure out how I take care of that. So let's take a look at it and see what it would do. I have 3 times the whole quantity, 5n minus 1, raised to the 1/3 power, minus 2 equaling 0. Holy cow, lots of stuff there, okay? The first thing that I see that I can get rid of is that positive or that negative 2 there. I'm going to add 2 to both sides, okay? Because that's a constant outside of my variable term. So then I have 3 times 5n minus 1 raised to the 1/3 power is equal to 2. The next thing that I see that I want to get rid of is I'm going to divide both sides by 3 to get rid of that 3 that's on the outside of my variable term. So now I have 5n minus 1 raised to the 1/3 power equaling 2/3. Okay, now that 1/3 power, in order to get rid of that 1/3 power, I want it to be raised to the first. So to get that to be raised to the first power, I need to take the whole thing and cube it. Because we all know power of a power means I multiply those together. And if I multiply 3 and 1/3, I end up with 1. But again, if I cube the left side, I have to also cube the right side. All right, I'm going to stop there for now, and that's going to be the end of our video. So thanks for watching, and please pop back to Schoology and take your quiz. I'll see you over tomorrow.